So when it comes to naming monatomic ions, there are two simple rules. One for things that are cations. Remember, cations are positive and cations are the metals. So that kind of lower left section of the periodic table. These are the easiest ones to name. Their name stays the same. The name of their cation is exactly the same as their original element. So if you go on your periodic table and you look up magnesium, magnesium has an atomic number of 12. You will see that Mg is magnesium and Mg2+, the cation, is also called magnesium. So then if you go find Na on the periodic table and you look up its name is sodium, and Na+ is also called sodium. Super easy, super awesome. Enjoy that little win. They're not all quite such easy rules. So the next one is for an anion. So this is the nonmetals. This is the upper right-hand portion of the periodic table. This is above the stair-stepping line over here. This group that form anions have their root name and then IDE ending. And basically we take two vowels off. So what I mean by that, so if you look over here, chlorine, we're going to take off two vowels. So the first vowel is E, the second vowel is I, and then we put on a new ending, IDE. So chloride. And that sounds right to you, right? Because we've known about sodium chloride this whole time. We just didn't know that we were naming its ion at the time. A trickier one is oxygen. So the first vowel is this E, and the second vowel, and sometimes Y, is the Y. So we take off the two vowels and we add IDE. So we call that oxide. So O2- name is oxide. O's name is oxygen. O2-'s name, oxide. So you now know how to name monatomic ions. So this is a quick summary that has a lot of the common monatomic ions that you might see, and it has their name. So remember that the cations, this is not worth writing down because these are the names that are written on the periodic table. So if you go find Ca on the periodic table, right underneath it, it says calcium. So please don't write down right now that Ca is calcium, because when you go check it on your periodic table, you're going to see that calcium's name is already written on the periodic table, so there's no need to write it down. For the anions, we keep the root and we change it to IDE. So if it's hydrogen, it becomes hydride. Fluorine becomes fluoride. Chlorine, chloride. Bromine, bromide. Iodine becomes iodide, which is a funny one. Kind of sounds tricky. Oxygen becomes oxide. Sulfur, sulfide. Nitrogen, can you guess, becomes nitride. Good. Phosphorus becomes phosphide. And so those are the anions that we have to consider their name. So many of you guys have asked about the D block. We've kind of ignored the D block up to this moment, or up to this chapter. And so what we're going to be doing is talking about how we might name using the D block. And it's actually pretty simple. Because they're cations, they keep their same name. So iron, Fe, iron is iron. And aluminum, Al, is aluminum. The difference is that we have to identify their charge. To distinguish between the charges, we just put Roman numerals in parentheses to identify their different charges. So if we have iron with a 2+ charge, we write it out as iron and then a 2 in Roman numerals, and we call it iron 2. And so if we have iron with a 3+ charge, we write it as iron, again with a 3 in Roman numerals, and we call that iron 3. And this is called the stock system of nomenclature, and it's the easier of the different systems that they have. This is the easiest one. And so when you look at the different elements of the D block, what you see is that those that have multiple charges all have Roman numerals here. So like copper 2, and then we can go over here and there's copper 1. or there's lead-2, and then there's also lead-3 and even lead-4 that are different ions that lead can form. And we have tin-4 and tin-2. So very simple. We just put the Roman numeral to give it a charge. But there are 4 rogue, weird ones in here. Okay, there's always an exception to your rules, right? So as a general rule, every D and P block metal requires a Roman numeral except silver, zinc, aluminum, and cadmium. Silver, zinc, aluminum, and cadmium do not get Roman numerals because they can only have one charge. So when we write those ones, we write Ag plus, its name is just silver, not silver 1. And that's because there's only one option for silver's charge. The same thing is true of zinc, aluminum, and cadmium. So zinc is just zinc, not zinc 2. So this is something that you have to watch out for. You have to have an eye up for while you're working. One thing I do want to show you is how to remember their charges since they're not written in their names and it's not their group number. So we're going to excise, we're going to look at what they look like outside of the periodic table. These are the 4 boxes. If we just kind of pull them out, these are the 4 boxes that are represented by those 4 exceptions. And so they fill in like this. This one's silver, Ag, and then cadmium, Cd, zinc, Zn, and aluminum, Al. And so how this works is that this is group 11, group 12, and group 13. And the charges are 1 plus for this one, 2 plus for the ones in this row, and 3 plus for aluminum. And so even though they're not in like a consistent position, like everything in group 2 is plus 2, like we see here, right? Everything in group 2 is plus 2. We find silver, cadmium, zinc, and aluminum in these 4 boxes. And again, because we're in group 11, we know that silver is a 1 plus charge. Group 12, zinc and cadmium are 2 plus charges, and group 13, that gives aluminum a 3 plus charge. And so that's a way to kind of keep those ones straight in your memory. And again, you guys should have a periodic table that you are writing all over just like I am, so that when you get to the test, you're ready to just write down all of this stuff or use all of these pieces of information to make the test really, really easy. This is a huge advantage of at-home learning. All right, you guys, that was a big day of learning how to name monatomic ions. And the good news is that tomorrow, when we learn to name ionic compounds, we're really just putting these 2 names right next to each other. So most of what we have to learn tomorrow is what we learned again today. So we get to review it. All right, you guys, I'll see you in class where we get to do some practice.